All right, so question 12 and 13 are the same, so we'll do one of these. Suppose you'd like to purchase, and actually, are they exactly the same? Well, they are on mine. I don't know if they will be on yours, so we'll see. So suppose you'd like to purchase a new Mustang GT. Sticker price of the Mustang you want is $41,675. The dealer is able to give you an APR of 4.85% for 4 years. How much will your monthly payments be? So we are taking a loan here. So first we want to figure out what our payments are, and then we're going to figure out how much we'll pay in interest once the loan is paid off. So let me copy this part first. Since it is a loan, we're going to use our payout annuity formula. All right, but let me go grab the loan formula from our formula sheet. There it is. Okay, so let's identify everything that we've got. We don't know the amount of the payments, and that's our D. That's what we're going to be solving for. But let's notice that we do have the initial amount that we are taking the loan for. That's our P sub 0. So P sub 0 is our 41,675. Our interest rate is 4.85%. So as a decimal, that's 0.0485. We're going to do this for 4 years, so N is 4. And then we are making monthly payments, which means we're doing this 12 times per year. Okay, so let's fill in. We'll have our 41,675 on the left. D is what we don't know. 1 minus 1 plus 0.0485 over K is 12 raised to the negative 4 times 12, and all of that is over R over K, 0.0485 over 12. All right, so just like before, we need to work the little inner parentheses first. So we need to do the 1 plus 0.0485 divided by 12 first. So I'll just kind of rewrite the rest of it. That gives me 1.00404 1667, and that is raised to the negative 48 power all over. And remember, we can kind of shortcut this. It's just the decimal portion of that number. All right, so let's do this now to the negative 48. Be sure when you raise it to the negative 48 to put that negative 48 in parentheses. So I'll get 1 minus 0.8239 0808. Oops, I'm sorry, it's 0008. And all of that over this. So I get 41,675. Now let's do the 1 minus the 0.8239, blah, blah, blah there. That's going to give 0.176019992 over this one. All right, and now let's go ahead and let's divide out what remains with the D. So, look very much like D. We're going to divide this by this. And I got 43.55133.463. And then last step, let's get D by itself by dividing out what's with it. So we're going to divide both sides by 43.55133.463. So that will go away, and we'll get D equals whatever this turns out to be. $956.92. Okay, now that was the first part of the problem. We had to find the amount of our payment that we're going to be making on our loan. So it's a pretty expensive car, but it is a $42,000 car. How much will you have paid in interest once the loan is paid off? All right, so let's keep in mind we're paying this loan for 4 years, and we're paying that $900 every month. So let's look at what we're paying. We are paying $956.92 for 4 years every month, so 12 times a year. So let's multiply all that together, and that will tell us how much we're actually going to end up paying for this car. So we're ending up paying $45,932, and it rounds to 0 cents here. Okay, now let's notice that what we pay is, of course, more than the loan that we originally took. So to find the interest, we'll just take what we paid, which is this, and subtract off the amount of the loan, and that's going to tell us the amount of interest that we're paying. All right, so 45932 minus 41675, and we get 42. We've got $57 in interest. Now let's look at one more. Haley refinanced her home loan. The new loan of $81,000 has an interest rate of 3.7% compounded monthly. She's planning to pay off the loan in 17 years. What will her monthly payment be? All right, and we have several questions to answer, but let's start with that monthly payment. I'm going to copy that thing and paste it again. It's a loan, so we're going to use the same loan formula we did for the car. And so let's identify everything. This right here is our initial amount that we are getting the loan for. That's our P sub 0. Our interest rate is 3.7, but we want it as a decimal. We're compounding monthly, so K is 12. And we're going to pay it off in 17 years, so N is 17. Okay, so let's plug in. We're going to have 81,000 equals D, 1 minus 1 plus 0.037 divided by 12 raised to the negative 17 times 12 over 0.037 over 12. Now, just as before, let's get the little parentheses first. So 1 plus 0.037 divided by 12. So that ends up being 1.00308333333. And I went ahead and multiplied my negative 17 times 12, and my exponent is negative 204. And then, of course, remember the bottom is always just this part of the decimal right here. So now we need to do this 1.003083333 raised to the negative 204 power. And that gives 0.5336408,603. And then let's do the subtraction. 1 minus that number. And that is 0.4663591,1397. Now let's finish dividing that by the number on the bottom here. We get 151.25177764. And then lastly, let's solve for D by dividing out that 151 on both sides. And we get that the monthly payment is $535.53. All right, now that answers the first part of the question. Let's look at the second part. We want to know, assuming Haley paid all the payments on time and did not prepay the loan, we want to know what's the total amount paid and the total amount of interest. Okay, so let's get the total amount paid first. So if we go back here, she paid $535.53 each month, so that's 12 times a year, for 17 years. So 17 years. And let's multiply that out. That gives $109,248.30. All right, now that's what she paid. Let's subtract off the actual amount of the loan, and we will get the amount in interest. So this minus the $81,000 that she borrowed gives us $28,248.30 in interest. And there we have it.